When you hear chemicals, it can sound vague and intimidating. But in practice, this industry is a very structured system of businesses that turn raw materials into highly targeted solutions. Fertilizers that boost crop yields, coatings that protect buildings, materials inside your phone, flavors and colors in your food, and chemistries that help decarbonize the economy. I will be walking you through the chemicals and agricultural inputs industry, what each segment does, how it creates value, how it links to the broader value chain, what investors watch when evaluating these businesses. The big picture, value chain architecture. The map forms four major layers, plus one agriculture-specific vertical. 1. Base or industrial foundations. Industrial chemicals, materials, gases, water process services. 2. Advanced and specialty materials, polymers, case systems. 3. End market solutions, ingredients, flavors, and colors, energy, mobility, and environmental solutions. 4. Agricultural inputs, fertilizers, crop protection, seeds, and ag retail. Think of it as a stack, base at the bottom, applications at the top, agriculture running parallel. When we talk about agricultural inputs and crop science, we're really talking about the part of the value chain that sits closest to the farmer, the products and channels designed to improve crop yields and resilience. This space is built on four pillars. First, fertilizers and nutrient products, where producers blend nitrogen, phosphate, and potash materials like ammonia and DAP, all heavily influenced by global nutrient pricing and commodity cycles. Second, crop protection chemicals and biologicals, including herbicides and insecticides, whose demand shifts with planted acreage, pest pressure, and regulation. Third, seeds, traits, and genetics platforms, where companies develop high-performance seed technologies that boost yield and resilience, shaped by farmer economics and regulatory approvals. And finally, ag retail and distribution, the commercial engine that connects manufacturers to farmers, managing inventory, pricing, and on-ground agronomic support. Together, these pillars form the farm-facing system that drives modern crop production. Industrial chemicals and materials form the core feedstocks that so many downstream sectors rely on. This space spans basic and intermediate chemicals, derivatives, pigments, and engineered materials, all of which sit at the center of major value chains. At the foundation are basic and intermediate chemicals like chloralkali, olefins, methanol, and acetals. These producers run large-scale acids, where economics hinge on spreads, feedstock and energy costs, and capacity utilization. Moving downstream, chemical derivatives and intermediates add value through integration and product mix, supplying multiple end markets, and acting as the bridge between base chemicals and final formulations. Then we have pigments and colorant materials, which go into coatings, plastics, construction, and manufacturing, with demand tied closely to industrial and consumer activity. And finally, engineered materials and specialty formulations, designed for coatings, plastics, fibers, and advanced applications, where customers pay for performance, reliability, and strict qualification standards. Together, these layers form the backbone of modern manufacturing. Polymers and advanced materials focus on engineered, high-performance solutions that serve the most demanding applications. This segment includes engineered resins, composites, electronic materials, and emerging circular recycling platforms. Producers of engineered resins and specialty plastics compete through durability, regulatory compliance, and winning key specifications. Composites and structural materials support sectors where strength to weight and long service life are essential. Electronic chemistries and materials enable the reliability required in semiconductor and electronics end markets. And circular polymer platforms push the industry toward recycling and sustainability. Across all of this, value comes from performance, application development, and maintaining OEM specifications in packaging, automotive, electronics, medical, and filtration. Investors focus heavily on spec retention and alignment with these high-spec markets. Coatings, adhesives, and construction chemicals, or CASE, take upstream chemistries and convert them into formulated systems that protect, seal, bond, and decorate the built environment. At the center are protective and decorative coatings where performance, durability, and aesthetics drive specification and brand loyalty across both new projects and maintenance cycles. Adhesives and sealants provide the bonding and reliability needed in construction and industrial settings. The segment also includes powder, waterborne, and high solids technology platforms, which reflect the industry's push toward regulatory compliance and lower emission systems. And finally, brands, tinting systems, and store pro channels create real pricing power and customer stickiness, making channel strategy a major competitive advantage. Together, CASE businesses deliver the high-performance systems that hold and protect modern infrastructure. Energy, mobility, and environmental solutions sit at the intersection of chemicals, transportation, and decarbonization. This segment provides the chemistries that support vehicles, fuels, climate technologies, and safety systems. It includes battery and energy storage materials, where demand shifts with vehicle fleets, mileage, and energy policy. Tire and mobility additives enhance durability and safety and move with vehicle usage and replacement cycles. Fuel additives and emissions control chemistries respond directly to emission standards and regulatory change. We also see refrigerants and fire safety materials, driven by thermal management needs and strict safety frameworks. And finally, chemistries tied to RNG, SAF, and environmental absorbance, which play a growing role in decarbonization projects. Together, these technologies act as a bridge between the chemical industry and global climate and mobility transitions. Industrial gases and water process services operate almost like utilities for the industrial world, delivering the chemistries and support systems that keep plants running safely and reliably. At the core are on-site industrial gas supply contracts, structured much like utility agreements, where revenues track industrial uptime and throughput. Supporting this are water, sulfur, and process treatment services, which ensure reliability and environmental compliance across refineries and chemical plants. The segment also includes cleaning, surfactant, and hygiene chemistries, essential for process stability and industry-wide hygiene standards. And finally, regeneration and field service networks, which maintain equipment, optimize chemistries, and build deep customer stickiness through technical support. Together, these systems provide the behind-the-scenes utilities that enable modern industrial operations. Ingredients, flavors, and colors are the consumer-facing side of the chemicals value chain, the inputs that shape taste, nutrition, appearance, and overall sensory experience. This segment includes flavors, fragrances, and taste systems, which define how food and beverage products smell and taste. It also spans nutrition and wellness ingredients, supporting the industry's shift toward healthier, functional products. Colors and appearance modifiers, including natural colors, influence branding, perceived quality, and clean label positioning. What really differentiates this space is its application labs, regulatory expertise, and customer co-development, where companies work directly with brands to design formulations that meet taste, nutrition, and compliance requirements. It's a high-touch, expertise-driven model where science and regulation translate directly into consumer experience. When we step back, the chemicals and agricultural inputs landscape can be viewed as layers of value. Base layers, like industrial chemicals, materials, and industrial gases, are cyclical and spread-driven. Middle layers, such as polymers, advanced materials, and CASE, are specification-driven, turning feedstocks into high-performance formulations. Top layers, including ingredients, flavors, and colors, and energy, mobility, and environmental solutions, are consumer and application-facing. Agriculture forms its own chain, tied to yields, acreage, pest pressure, regulation, and trait adoption. Investors evaluate exposure across upstream, specialty, and end market segments, watching cycles, policy shifts, technology platforms, and distribution ecosystems. This map helps compare business models and anticipate how shocks ripple across the system, from raw feedstocks to consumer-facing applications, giving a complete view of value creation across the industry.